Welcome to qnawire.
So here we're essentially given a certain surface that has a radius of 20 meters, and we're given information that the speed is increasing in the following direction by 0.600 meters per second squared. And so this is essentially equivalent to the tangential linear acceleration. So the tangential acceleration component is equivalent to the following. So this is our first part. Since essentially the tangential acceleration component is the only component that can provide an increase in the instantaneous speed. And this is equivalent to essentially the radius times the angular acceleration. And we can find through this process that the angular acceleration would be equivalent to essentially 0.03 radians per second squared. And at this certain point in time, we're given that the velocity is essentially 4 meters per second. So the centripetal acceleration is known to be v squared divided by the radius. And as a result, we can find that this is equivalent to 0.80 meters per second squared. And the total acceleration, since the tangential acceleration is in the following direction, while the centripetal acceleration is pointing towards the center of the circle, the net acceleration is essentially the vector sum of these two vectors. As a result, we can see that the magnitude of the acceleration is equivalent to 1 meter per second squared. And now mainly we have to choose a direction to define essentially our theta. So we can define our direction relative to our tangential acceleration, which means we would have to take the inverse tangent of the following quantity if we define it relative to our tangential acceleration. As a result, we have the inverse tangent of 0.8 divided by 0.6. And we can see that theta is essentially equivalent to about 53.1 degrees, essentially north of the tangential acceleration. And this gives our final answer.